Oh, what's going on, guys? In this video I'm going to introduce you to the principles of orthographic projections, and then later on we're going to look at somewhat complicated drawing, and finally you can check out the later videos on this channel for more examples on drawings in orthographic projections. Okay, so let's get started. Orthographic projection is all about representation of a 3D object in terms of its views. So we normally choose three principal views: the plan, the front elevation, and an end view. So before you get on to choosing which is the end view, we need to decide which side to take as the front view. Okay, so normally that depends on what you choose as the front view. There's no standard front view of any object, but at least we know that the top is always the plan of the object. But depending on what you choose as the front view, the rest of the views are decided after choosing the front view. So that's why I wrote here end view as seen from the right of the given front view. Otherwise, if we chose this the unshaded region as our front view, then the end view as seen from the right would be the red part. Okay, so usually we have three principal views: the front, the plan, and then the end view, and all we have to do is to represent them as they should appear if I was to look directly in the direction of the arrows. And this is basically what we do here. So we have two standard projections that we normally use. We have the first angle orthographic projection and the third angle orthographic projection. The difference is in the arrangement of the views. So in first angle orthographic projection, we start with the front and then project lines downwards in order to produce the plan of the same object. Okay, so start with the front, then the plan should be below. So the end as seen from the right, we'll have to put it on the opposite of the front. Same thing with the plan is on top, so we put it below. So that's first angle orthographic projection, well, in simple terms, but you can check out the text for detailed explanations on how we come up with first angle and third angle. We actually have all four angles: first, second, third, and fourth. But with this engineering drawing or geometrical construction and building construction and whatnot, we normally stick to these two angles, first and third angle. So third angle just simply means we put the views in their respective places. Like the front, we started with the front, then we put the top view or the plan on top, just like how it should naturally appear. Okay, just like the way you see here, we have a plan, then the top is the plan, then the end view as seen from the right, we still put it on the right of the front. Okay, and then one other thing is, as we project the lines to form the third view, those lines have to be at an angle 45 from whichever view you're projecting them from. Okay, so that's very important. You use an angle, you project them at an angle 45. Once they reach the horizontal line, then you stretch them, or you stretch them towards the vertical. Okay, so that's very important. Otherwise, if they're on a different angle, then the end view is going to be wrong. Okay, so same thing here. You start with the front, project the lines vertically downwards to get the plan, and in order to get these mark-off points, we just measure directly from the given information. So usually you are given some kind of information like width of this, so that is the exact measurement you take to mark off these points. So same thing here with the two views complete, front and plan. We simply project lines and project also lines from the plan to form the end view. There's no more need of taking measurements from whichever information is provided. So the same principle could be adapted for any other view. As long as you have two of the views, you can easily produce a third view or fourth and so on. Right, so the reason we have a green line here is that the end as seen from the right shows a flat surface. It's just a flat surface. It's like a flat wall. There's no step. So from this end there's no step. So if you are to represent it, you represent with an outline. So if you are to represent this step that is not seen, then you have to use a dashed line. It doesn't have to be green, but at least it has to be dashed. That is for hidden details, because that part is hidden, so it has to be dashed. Okay, so it's the same thing here. Okay, because this is, if I'm looking from this end, that is that end, I won't be able to see this. Okay, so the green line represents that kind of edge, right? Because we have a step here, so it's got to be an edge there, and we have to represent it in this view, in this two-dimensional view. Okay, so also we have some symbols. Now this symbol represents first angle orthographic projection. Why? Because you just assume this is a cone or a conic section. Okay, just imagine it was a full cone and then the tip was cut off. So if I look from this end, say I have one of those arrows here, these arrows, if I placed it here, meaning the direction of view, I look from this end, I'm going to see two concentric circles. Okay, so meaning that the view from this side is drawn on the right, okay, but not on the side from which I'm viewing it from. So that's basically first angle projection. Okay, so same thing here. Third angle means whatever I see from this side, I have to draw this side. So that is why we have two concentric circles here, and then the other shape we have it here. So these are just the standard symbols we use. So sometimes you won't see the actual name third angle orthographic projection, but you just see symbols. If you see these symbols on one of layouts, then it would mean the drawing is in third angle orthographic projection, and if the arrangement is like this, then the drawing is in first angle orthographic projection. So there's no need for the wording, because not everybody is able to understand English. Some people speak Chinese, French, Russian and so on, so they won't be able to understand what this means. But the symbol is just a standard way of saying this is first angle and this is third angle. Right, so yeah, now that we've gotten all the technicalities out of the way, let us look at drawing a slightly complicated drawing. So we have this we have a figure shows an elevation of 20 millimeter square prism, 50 millimeters long, resting on one of these corners and horizontal plane. Draw to full size the views and so on, the hidden details, the given elevation, the end as seen from the side, and a plan projected beneath the view A. Okay, alright, so the plan projected beneath the view A, so we have a plan down, and then the end as seen from this side, we just draw it here. if we are to use first angle orthographic projection. Okay, so now the first task here is to determine actually where this line is, because we are not given any measurements here. We're not given any measurement at all. So our first task is to determine where this line is. The rest is easy to do. We just draw a line here inclined at 30 degrees, but now determining this line. Okay, so this is one of the edges of the the prism. Okay, so the prism was twisted and then tilted so that it rests on one of the corners. So yeah, but at least we are given the elevation. So the first thing we are going to do is to draw a square 20 millimeters, and then we make sure the diagonal of that square is at this elevation 30 degrees to the horizontal line. Then that way we'll be able to project lines from that square to complete this shape. Alright, so let's go over to AutoCAD and get the line tool. Make sure you are working in layer 0. So get the line tool, and no, actually not the line tool. So we get the rectangle tool, and as we attempt to draw a rectangle, we just specify by dimension, enter 20, and the width is also 20. So we have that. Okay, so we have this we have this rectangle. And now the other thing is we are going to draw a line at the elevation 30. Okay, should be 30 to the horizontal. We'll go ahead and get the line tool. So I'll simply draw from here going this side. It should be 150. Okay, so that's very important. You should already know how you come up with those angles. Okay, you don't expect to see 30, but you should see 150, because we're measuring from the positive x direction going counterclockwise. Okay, start from here, that is 0, going up, up, up. So if I have 150, it means I have a difference of 30 to get to 180. So that makes it 150. Okay, so just click there, and now the other thing is what we're going to do is just simply move this and make it sit here. So move, I'll pick it, and I want it to, okay, just it could just sit there for now. So just make sure it's properly sitting on that endpoint is sitting on the line. So that's good enough. Now I'm going to rotate this so that this corner also sits on the line. Right, so for that we select the object type RO, short for rotate, click enter, and select the base point. This is going to be my base point, and we don't rotate like this. We want to rotate by reference instead. So you could either click here or simply type R for reference. Let's enter. Now we have to specify the reference angle, so you simply draw a line from that point to this corner. Okay, well, it should say end point, to that point. Okay, and now we simply move that to intersect with the line, and yeah, we are done. Okay, now the other thing is we simply copy this line. So this whole thing will appear at the top. So what we need is the bottom line, so that we project lines from the top to meet the bottom line in order to form these 3 lines. Alright, okay, so in order to draw the baseline, I'm simply going to copy this line, or still draw another one at the same elevation 30. So that should be very easy. So instead of copying, let me just draw another line at the that same elevation. So I'll just look for the angle 150. Maybe that's too close. I'm not sure. I think it's too close. So let me just draw it somewhere over here. So I'm looking for the angle 150. So that's the one. Click and you're done. Now, in order to project lines to meet here, because those lines have to be perpendicular. So we are projecting lines from somewhere here, going down. So they are perpendicular to this line, that the one I've just drawn. So for that we go over here and activate, or we should activate perpendicular. It's here. Whatever is not important, we can turn it off. So we have perpendicular. Apparent intersection is usually important. Intersection is also important at some point. Endpoint is like the default, so we leave it on. Alright, so we come here and click align tool. Now we want to project this endpoint perpendicularly to this. So we just wait for, if we see that caption perpendicular, we click and do the same thing for the other points. So this one should be in line with that one and basically perpendicular to this one. Click and look for perpendicular. Then the last point, make sure you take the end point, not the intersection. Sometimes it can get confusing if you take the intersection. So look for perpendicular again and click. So that is it. Now we need to measure off the distance of 50, because this is 50 millimeters, so we take off 50. So get the line tool, starting from here, and we want to move along this line, so simply type 50, click, and also look for perpendicular, click. Okay, so I'll just go around to finish this like that, and also I'll just draw over this like that. Why? Because I want to outline these. Just want to outline these, and I don't want to trim, so that's why I drew over them. So just outline like that, and so the first task is done, and now we need to project downwards to form our plan. Okay, so for that we get the line still and click the end point. Make sure you take the end point, not the intersection, just take the end point vertically downwards somewhere there, and take that end point there, then this over there, and okay, so you take that one. Well, they don't intersect, so they're just so close to each other. From afar they appear to intersect, but they actually don't intersect. So take this one as well, and finally take it should be the end point there. Sometimes you get errors if you take intersection, so just take the end point. Okay, now we are going to put some bit of spacing between the front and the plan. So again, we are using first angle. We are using this first angle where we have a front, then plan below, and the end elevation are seen from the right, and we put it on the left of the front. So it's the same thing we are doing here. So we projected the lines from the front. Now we need to start drawing the plan. So we need to put some equal spacing between the views. Okay, just like here I put between this view and this view there's 10 millimeters. Same distance we have between this and this. So that is so that distance depends on really the scale at which you're looking at your views. It's not a standard amount of distance you should leave. you can decide on your own how much space you want to leave. So from the very end point, that's where you need to okay, so from the end point, that's where you need to measure off that distance. So I'm going to take a distance of let me just make 20. So 20, this is what 20 gives me. So yeah, my plan is going to start from that line. So that's my line, okay, over there. And now the measurements for the plan, since we already know it's a prism that has been tilted on its it's resting on one of the corners, so that distance, the more of the width of that plan, because this is like the length of the plan, so we need the width of the plan. We're going to take this diagonal distance from here to here. Okay, now for that we can just measure that distance. So from here to this corner, okay, so from there to that corner we get a distance of that much. It's 28, but this is not a very perfect method. Okay, simply measuring that distance like that is not a very perfect method, so I'm going to show you a perfect method. Right, so what we're going to do is to redraw the same square somewhere here, and then tilt it in a way that we get one of the corners to touch this line. Okay, so that's what we're going to do. So just get this tool, draw out our square. Okay, and then we're going to just move it, rotate it, so that it's okay. I'm going to rotate this point, and yeah, still we use reference. So I want to rotate the diagonal so that the diagonal is at 180 degrees there. Okay, so now we are ready to move that square to touch this point. We just move it so that it touches, there, just there. Okay, move it so that it touches that line. That is all we want. So then we project lines from the, just like what we did with the plan. So just simply project the line. Well, don't get me wrong, this is not the true shape of the plan. It's not the true shape of how the plan appears. Okay, this is the true shape of the object, but it's not the true shape which is supposed to appear here as seen from here. Okay, so that is not the true shape. So this is just to help us draw these lines like that, and also draw this perpendicular is still turned on, so I better go and turn it off. Okay, so we have this as our plan thing. So what we need to do now is to locate the points of intersection. Okay, so each line should intersect exactly with the corresponding line. Okay, so this is for the edge, for this edge, so that point is equivalent to a point coming from either here or here. So it means this point should intersect with that line, and this point is equivalent to either this point or that point. So that means this line should intersect with the line here and there. So the same applies for this one, should intersect with a point here, okay, because this point represents a point coming from here. So for that, let me just use an outline direct. So get the line tool and I'm going to simply draw from that intersection and go to this intersection, then come all the way to this, then here, then finally back here. Okay, so as seen from the top, that is how that shape looks. Okay. Then for the other parts, it should be easy to navigate, so I'll just draw from here to this point. I'll simply go here, then come over here, that end point there, then continue to this end point. Okay, so from the top, this is what you're going to see. Oh, there's one more line missing for the edge. There's that edge from here to there, so that point. Okay, so at the top, this is how the prism, the inverted prism is going to, okay, it's not inverted, it's just a tilted prism. This is how it's going to appear from the top. Okay, as you can see, this shape is quite different from this one. Okay, this is an actual square just rotated, and then this is a more of a rhombus shape. Okay, so now for the hidden part, we could just go to the hidden layer, and I'm going to quickly draw the hidden part. So from here to this point, okay, not the other point, because these two lines are different, then to this point. Now the line behind, we only draw it from that point to somewhere here. Okay, although it's supposed to go all the way there, but since we already have an outline there, we don't interfere with the outline. Okay, so we give the outline priority. So if the outline intersects with the hidden line, then we give the outline priority. So we just draw it to about that point. Okay, so this line coming from here to, it should come all the way there, but we're not making it go there, represents this line. Okay, that edge, because vertically above you won't be able to see that edge, so that's why we are representing it as hidden. Okay, so our plan is done. Now what we're left with is the end elevation as seen from this side. So that is going to be here. So what I'll do, I'll go back to the construction, and so from this point I want to actually should be this is the base point. From the base point, I'm going to project line 180 there, then I'm going to project here. Line should be straight. Then I'll project this one also 180 degrees, and 3 more lines is so I still emphasize you take endpoint, not intersection. You just take endpoint. Take endpoint. If it's possible, you take endpoint. Okay, now one last point should be there, from there to there. Okay, so let me lengthen this a little bit to that point. Alright, so yeah, now all we are left with are the vertical lines. So what we're going to do is to get the first line, we just have to project so you see this point, project it to the farthest point. So this is our farthest point in terms of the plan. So we project this point to that point that corresponds to the farthest point on the plan, and then it's from here that we are going to draw the line at an angle of 45. So at 45 degrees we should have an angle of 135, okay, because the difference will be 45. So at 135 means we are left with 45 degrees to reach 180. So that elevation, the line is at an elevation of 45. So we are using intersection, so we just cross there and we continue vertically upwards. Okay, very easy, just continue upwards. And again we take the other point. We only need 3 points from here, so the other end point, that one is already the farthest point, so also look for the angle as 135, click, then go upwards 90 degrees, and do the same thing here for the last line over here, 135 there, then go vertically upwards. Okay, so you'll notice that we left a gap of from here to here we left 20. It's going to be the same gap from here to wherever our endpoint starts from, so we can verify that by simply measuring from here to okay, that part, and you can see the distance says 20 millimeters. Okay, so now we are ready to outline our endpoint. So as seen from here, we'll be able to see the top in a distorted fashion, just like the way we are seeing it in the plan, and we won't be able to see this part because it will be hidden. So again, I'll just simply use the outline and outline layer, then I'm going to draw over here. Okay, in fact I'll just start from here for some obvious reason that you will see later on. I'll just start from there and there, so that I'm able to just continue downwards. Okay, save us a lot of time. Just continue downwards like this, and then we have that intersection there, then we complete the drawing like that. So then we'll be able to see this line, although it was hidden in the plan. So in the plan, that is the green line here, but here we are able to see it. Okay, so it's that same line. In the plan is hidden, in the front is just that, and then in the end view this is what we're able to see. So here in the front view is represented by that, and the one which is hidden. So since it's hidden and it's in line with this one, we don't need to put a dotted line. Okay, so the outline takes priority, but the one we can't see from the front is this line. Okay, yeah. So you just imagine yourself standing here and looking directly here, so this is what you're going to see. So the top is going to be the top. Okay, so now we're left with the hidden part. Okay, so for that part we can switch over to the hidden layer and we can draw the hidden, from there to that end point, and then we also need to show this line, okay, because it will be hidden. So it starts from here, so that is that point, and then it goes upwards to that point. So since the outline is taking priority, we don't need to draw the green line over the outline, so we just start drawing from there. Okay, we don't want to interfere with the outline. Alright, so that is our drawing is done. Maybe I can just shade it a little bit for you to see what it actually is. Okay, I'll use a different layer. I'll use the that layer. Then I'll just add this, make it 10 here. So I'll shade that part to make it stand out. Okay. Yeah. Okay. Maybe we can give it a different color. We can give it that color. Okay. So yeah, I'm just putting the color so that to show you that you can see that part. It's at top, so you can see it in that view. So in the plan, in the front, we are not able to see it, but in the plan, we're able to see it like that. I'm not shading the bottom because we are not able to see the bottom. So same thing here, from the end view, we are able to see that part. So that's why I'm shading it like that. Okay. Yeah. Okay. So yeah, that is it. And you can check out the other videos for a couple of examples on orthographic projection. Right.